anyone in the back see the screen? No? Sorry.
Yeah.
What about this? Better?
Yeah.
How does this look like? No, not really. It's a little bit dark, but this is better, right? Yeah, so this class will have a YouTube streaming, and it's not working as intended, so the TA is still setting it up. Just give me a few more minutes. Let's see what's going on.
It's just a zero. I mean, it's recording. It doesn't show.
It's recording, but doesn't show anything. Yeah. Why not let's just go with the recording and we can upload it later. Yeah.
Just go ahead.
Alright. Let's get started. So So welcome to CS 6530 database systems. So Fei is out of town. He's on leave this semester. So I'm his third year PhD student, and I will give these lectures instead of him. This class will be in this room on Tuesday and Thursday, 12:25 to 1:45 p.m. And we have two TAs. One of them is Dong Xie. He's sitting there setting up the camera, but it appears it doesn't work all the time. And we have another TA who's not here. He's going to be here next week. His name is Yanqing Peng. So about the office hours, so Dong will have his office hour on Monday, we say 2 p.m. to 3:30 p.m. And Yanqing will have his office hour from 1 p.m. to 2:30 p.m. on Wednesday. And I will hold office hours just after class, 2 p.m. to 3 p.m. And if you want more time, please feel free to contact me at my email. So how does that office hour work for you? Do you need some adjustments so that it will work for your schedule, or is it okay? Just let me know if all this time doesn't work for you, then we'll schedule some other time. Okay? You can just send an email or reach us through Canvas. Just post a discussion or send a message. Okay. So basically our office hour will be in Fei's office. It's in Web 2692. Where it's just across a glass door to the Ski Institute on the second floor. It's on this side of the building. Don't go to the other side where you have lower levels. Those are a different part. You can go up from the stairs here, or through the lower level. You can go through elevator. Then you need to go across the hallway and go across that glass door. And the office is, I think, once you get across the glass door, it's on your right-hand side and it's to the very end of the hallway. So if you have trouble to find it, just let me know. I'll try to give you some direction there. So that's just about logistics. So what's this course about? As you know, this is a graduate level database courses. This is different from the undergrad one, where what's covered are the design of databases, like how do you design a bunch of tables, design a schema, and design a web application based on a database. This course, instead, we will focus on the system side of the problem. So in this course, we are basically going to cover the database system from end to end. We are going to study the principle of database systems. So basically, we're going to cover like different modules of the database, such as the SQL parser, not really, just about the SQL language. You won't develop a SQL parser in this course. That's actually a different course, maybe a compiler or a program language. But we'll cover the design of SQL language, and we'll cover how the database system work as a whole, and what modules you have in the database system. Like you have optimizer, you have execution part, and you have the storage layer, and you have concurrency control, transaction processing, a whole bunch of stuff. So we're going to cover each of them, and by the end of the semester, we will have a bunch of labs for you to complete. This lab involves building a very simple database system, but although it's simple, but it covers all the parts of the essential database system. Yeah, so that's about the course. And so in addition to the traditional database, it's called Relational Database. Well, we will also try to cover a few newer database systems that's based on newer data models. As you know, the relational database is a quite old term, and it comes from, I guess, if I remember, it's from 70s and 80s. It's been used and widely adopted in industry for years, many years. But a newer trend of this is to use other models of other data models like graph or NoSQL, if you have heard of it. Like you also have some bulk synchronous data processing system like Spark, MapReduce, all those kinds of stuff. So we will try to cover a few of them, not thoroughly, just the introduction of them, and you will see some principle that doesn't change doesn't differ a lot from the traditional relational database. So yeah, that's about it. But if the time permits, of course, if the lectures take more time than intended, then probably we will just skip this part. And also this part, I think they won't be in your exams, so don't worry about it. It's just if you want to know and you can know something about it, it will be useful in your career life. Yeah, so that's it. And as I mentioned before, you will have labs. The lab is actually they form a semester-long project. This project will be based on a database framework called SimpleDB. It's written in Java, so that means basically your project will involve filling modules, implement some functions, methods, and data structures in Java. And we will hand out the skeleton of the code, and your responsibility is to fill in the details of those code. And there will be probably 5 labs if everything goes well. Each lab will be based on the previous one. That means if you do lab 1, your code will be also used in lab 2. We will hand out some additional files for you to fill in lab 2, and also you might need to change some files in lab 1 as well. With that being said, that doesn't mean if you fail lab 1, you cannot proceed with lab 2. If you do fail in lab 1, we will hand out a standard solution if you contact us to you. And you can base your later work, lab 2, lab 3, based on that standard solution. So don't worry about it. So the first lab will be out on in the 3rd week, the week of Labor Day, and sorry about that. But it's fine because the first lab, if I remember, is not very hard, and we will give you 2 weeks to complete. So yeah, so we will give you more details about that. Yeah, so one thing to know is that we would require you to use some kind of Git repository to manage your code. Like we prefer if you use Bitbucket because they allow unlimited number of private repositories. We require you keep your code private even after this course, so that later class won't be able to look at your solution and just copy it. And for the lab, I know there's a lot of solutions online. I tell you this. If you Google it, you can probably find a lot of code. And if you search simple DB in GitHub, you can find a lot of other people's solution, even in other institutes. Because this is not just used by us, it's used by a lot of people. But don't copy them. We will do a check on plagiarism. That means we will use a tool called Moss. It's basically, I can show you this here. So there's Moss. It's developed by Stanford. Yeah, it's just a system for detecting software similarity. That means it won't just compare the code. It will look for similar structures. If your code looks too similar, like just substituting the variable names, then it will detect that. So in the past, we actually find if there's plagiarism, then there's an outlier that has too much similarities. So then we will probably reach out to you to find out what's going on. If you have a legitimate reason, then probably we'll give it a pass. But if not, then you will get 0 points for that lab. That's it. Yeah. And so, as you know, the course project objectives, basically we hope by the end of this semester you will know a lot about the database system, know the design of it. And I think the most important takeaway message for you for this course is not actually how to implement the database. Rather, it's you know the internal of that, you know some of the details, so that when you later in your career, if you encounter some problems that requires you to tune the database, or you might want to wonder why this thing doesn't work as intended, you have some way to think about it. And if you know a lot about the internals, you might be able to tune the parameters of a database. As you know, there's a big file for every database, and it contains tons of parameters. So if you don't know about the internal of it, you won't be able to make sense of it. But if you know, then probably you will be able to adjust the knobs and make it work better for you. So that's the ultimate goal here. And also, like this course, throughout this course, we will also build a database system. As I said, it's a simple DB, and though it's simple, but it's complete. And that's gonna like give you a lot of understanding of how these database systems work. So yeah, that's about it. And so we will use Canvas for our homepage. So I think most of you should have looked at it, but I'll just show you just in case. So you can go to, you can go through the students, the CRS system. When you log in, you can open Canvas here, and
It's on our swing.
so and you will find CS6530 in your course tabs. And this is a bit different from what you see, but mostly you will see everything.
Hey, it's not on. You need to pull it
Oh,
over.
it's not here. Right. Sorry. Yeah. So if you go through your CIS, you will find Canvas here, Canvas login, and when you click through, you will find, sorry, I think it's dashboard, and you will find CS6530 here. When you click this, you will find like there's announcements, discussion, and files. That's the most important three, I guess, and also grades. So we will release our lecture slides in this part, in the files. In the slides, we've already released the first slide of this lecture. We will cover it later in the second half of this lecture. And probably we will release all the slides by the end of this week. So if you want to take a preview of the course, you can do it there. And also, just in case if you haven't looked at it, I suggest you look at the syllabus, which is this document here. It will contain all the information you probably need during the semester. And so there's this announcement tab. We will from time to time make announcements about written assignments, labs, exams, and also maybe if you do require some extension, maybe we will post it here. And if you have all other questions, you can go to this discussion tab here. We highly encourage you, if you have any questions, just post something on this discussion panel. Me, Dong, and Yanqing, we will try to get back to you as soon as possible when we see this. Typically, we will just reply to you in maybe 1 day or two, but if it's we see it immediately, we will immediately reply to you. But if we don't, just in case if we didn't see it or we were busy doing something else, this also gives you a forum to do discussion. So you can discuss about it yourself. We will definitely look at it. Even if you discuss it, we will post something that explains things more clearly to you. And yeah, in grades you will find the grades for everything later. And yeah, that's just about the intended use of Canvas. So basically everything we will post everything here. So do check it frequently. Yep. Let's move on. So yeah, there's one required textbook. Although it's called required, we don't actually require to have it if you are fine with all the slides. Basically, if you can fully understand all the slides and all the lectures, then you probably don't need to read through this book. But this is the official reference book, so all our contents will be based on this textbook. There's a direct mapping from the lectures to the chapters. So this book, yeah. Yeah, I think you can, if you do want to get this book, you can probably get it from any store. It looks like this. Database systems. Database. Yeah, I don't always remember the name of the book because it's got a more famous name because of the cover of it. It got a lot of cows on it, so that's why it's called a cow book. Yeah, and this is a bit expensive if you want to buy it, so you don't have to do this. But if you do want to learn more about database systems beyond the course, then probably you can take a look at it. And there are also some online resources. There's this database systems, the complete book. It's available online. You can also look at it if you want. But again, to get a good grade through this course and learn things well in this course, I guess the most important thing is understand all the slides and the lectures, and do the labs and written assignments properly. That will give you a good grade, and you will learn a lot from that. Yeah. So yeah, just and collaboration and academic honesty. Just don't copy others' work. Don't collaborate with other people without any reference. So I don't think that will apply to our situation, because in this course we do have written assignments, but they are not graded. So basically we will hand out the written assignments to you, and 2 weeks from the release date we will also release the solution for you to compare against. So that means basically you can talk about the written assignments with other people in the class freely, and you can. We won't need you handing the written assignments, and we won't grade it. So that actually doesn't apply to the written assignments. But for the lab, actually, this applies. So you can talk to different people, and you can discuss the ideas, but don't copy their code. And I would suggest you don't look at other people's code at all. You just discuss about the high-level ideas and discuss about the algorithms or whatever data structures you are using, but don't help other people your details. Otherwise, it probably will be picked up by the plagiarism check. Yeah. So right. So important dates. There will be a midterm and a final. Both will be in class. The midterm will be the first Tuesday after fall break. It's on October 16th. And the final will be also in class. It's the last lecture, December 6th, the Thursday, in the 16th week, I guess. And also note the last day to withdraw from the class is October 19th. If you, yeah, so if you do want to withdraw, then that's the final date for that. So grading part. So as I said, written assignment will constitute no part of your grade. We will have programming assignments. That's the project. It will have 50%, constitute about 50% of your final grade. That means we have 5 labs. Each of them will be assigned 10% of the final grade. So yeah, but from the experience, just from the past experience, so this actually will give you an advantage in the grades actually, because the programming assignments are easier to get a good grade, given you have a very long time to finish it, and it will not be hard if you can understand the lectures and you have some understanding how to write code. But just in case if you are not familiar with Java, or you've never done any system coding before, or you are not familiar with designing a system or designing algorithms, designing data structures, then probably you will need to make more efforts than other people. So I would suggest, if that applies to you, I suggest you start early for the lab, especially for the later labs, which are more time consuming and more error prone. yeah, the final lab is gonna be crazy, right? Because last time we did it, only one group. Oh, by the way, this will be the labs. The project will be done in group of 2, so you might want to talk to people to form the groups of 2. If you want to solo, it's also okay, but we won't give you any advantage of that. You are still bound by the same deadline requirements and the same standard to hand in the code. And you, still, if you do want to solo for some reason, any reason, just let me know later. We will post a survey link, and you can indicate there you want to do it as a single person group. Otherwise, it will be in a group of 2. Yeah. So, right. Just I mentioned last time we did this in the lab. The last lab we only have one group that get 100% of the points. All other people have some weird bugs in the concurrency control part, like logs. They can get dead logs, or maybe there's some concurrency control issue causing wrong answers. So be careful about the last one. Make sure, because it's to the end of the semester. So you probably will be more occupied with other stuff, like you have other courses. So make sure you start early on especially the last lab, so that you won't get a very bad result from it. Yeah. So yeah, I'm sorry about that. It's just that lab is a very important part of the database system, so you cannot just miss that. It's not going to take you a lot of effort to encoding, because it doesn't require a lot of too many lines of code. It's just you need to understand things and analyze the system thoroughly. So that's the issue. The midterm and the final will be open book. You can use whatever you want, textbooks, slides, printed or on your laptop, and also written assignments and their solutions. You can use, also you can print them out, or you can also use your laptop. You can also use your cell phone, but don't Google it. Don't use internet except campus. And of course, this is an exam, so you cannot collaborate with other people about the exams. You can only do it on your own. And since the exams will be in class, the class only lasts an hour and 20 minutes. So we will probably start the exam 10 minutes earlier than usual. So that means in those 2 classes where we have exams, we will start at 12:15 instead of 12:25. So we will send a reminder around that time, but just make sure you come earlier than usual for the exams. Yeah, and each of the exam will be 25% of your final grade. Yeah, so the midterm will cover everything up to what we cover in lecture by the time of midterm before fall break. And the final exam will mostly cover the things in the second half, but that doesn't mean we cannot have problems in the first half, but mostly it will not. It will mostly contain things in the second half, but it might have some references to the first half because it's a system, it's related. Everything is related, and you have different modules that interact with different parts. So when we have an exam, you cannot avoid things like that. But mostly, so if you at that time, we will probably also give you review lectures that will cover review everything that's covered in that half of the semester. So yeah, so mostly you will only need to focus on the first half for midterm and the second half for the final. And here's in the syllabus, we also have a final grade mapping to the areas A, B, C. So you can also take a look at it. This is just tentative, so if something doesn't work well, then probably we will change it. But if nothing just usually this perfectly matches the expectation of the grade, like it's normal distribution, right? So it will work fine, but if something goes different this year, then we'll make something different. Yeah. So late policies. So since written assignments are not handed in, so there's no such thing as a late. But for projects, we will we do not allow late submission because we already give you. I guess it's enough time. But just in case, if a lot of people are having trouble with the labs, just let us know, and we can make maybe a day or two extension to the deadline if like something that's really like during the around the midterm, if your time gets very tight and you have a lot of people have a lot of things to do, then maybe one day or two extension would be fine. And that will be like decided when it's almost due. So we can discuss about this later. But if we do not give you any extension, then the deadline is deadline. So you must have your submission done by the deadline. Yeah. So more about the projects. I think I already talked about this. Yeah, most of them I've already talked about them. And in the lecture, in the third week, in week 3, we will also give an overview of the project where we will have more details for you. So don't worry about this yet. And this is a tentative course schedule. And basically, so in the first half, we will first cover, do some, basically this course assumes you have some background in database, that you have background in undergrad database course. That means you should already know like schema, how to design database, things like that. But just in case, if you are not very familiar with that or you have forgotten about those parts, we have the first maybe 2 to 3 lectures covering the basics of relational model, which is just a basic data model for a traditional relational database. And also we will cover the basics of cycles so that you can be on the same page with us when we continue with the lectures. Then after those 2 to 3 lectures, we will continue to cover from bottom up, cover the database system from bottom up, from storage layer, files, heap files, then indexing like B-tree, hash table. Also, we will cover external sorting. And yeah, before fall break, we will likely to cover some part of query evaluation and optimization, but those we probably won't be able to finish it by the time of fall break. So that part will be continued after fall break, after the midterm, and so the midterm will only contain up to where we stopped. Like if we only cover a little bit about query evaluation, then maybe it won't appear in the midterm. So after the midterm, it's a query evaluation, optimization, and then we will cover transaction, concurrency control. If that makes any sense to you, if it doesn't, you will know in a later lecture. And also we will do crash recovery. Then if time permits, that's where we assign to weeks 12 to 14. We will cover some new systems, newer systems like NoSQL system or box synchronous system, graph system, key-value store. But if that's just additional to the course material. So you can learn something, but you don't have to worry about it in the final. That won't be part of it. If there's no time, just in case if the lecture doesn't go well, then it needs more time. Then for lecture 14 to 14, we will have some something else, like say just maybe crash recovery. Yeah. Also, let me know if you have anything that you are really interested about. If we have time left, we can also talk about it in those lectures. So in the week 15, that's the last week before the final exam. We will have a review class. We will wrap up everything we have covered in this course. And in the 16th week, we will have this final exam on Thursday. Probably on Tuesday. I'm not sure if there's a Tuesday lecture. Just we'll decide later, maybe about that. So that's about the overview of the course and some logistics. So any questions so far? Yeah, so if there's no questions, then we will continue with today's lecture. So we have about 40 minutes left, so we will just cover maybe a few overview of the database system. So why do we want to cover this relational model? Because when you say a database, you are basically managing a lot of data, right? So to manage a lot of data, you have to have some kind of model to model this data so that they can be stored in your system. Otherwise, it's just like bytes and bits. It doesn't make sense to the system, and it's not easy to manage, right? So, so that's why we're going to cover this. So let's first see a landscape of the database. Like we currently have, actually, if you broaden the concept of database to a few more systems, like not restricted to the traditional ones, you have a lot of different, I would say, data systems, like Hadoop, Spark, Hive. That's basically those box synchronous system, and they are basically not actively managing your storage. They are just doing a lot of querying over data, and they are easier to use on larger size of data to do some simple job, but not very complex daily transactions, say just like banking. That's not suitable, but for those systems, they are actually suitable to analysis of your data. And we also have a lot of NoSQL database like MongoDB, say Cassandra, something like that. And we'll also have in-memory database like MemSQL and traditional databases like MySQL, Postgres, SQL Server, Oracle DB, something like that. Yeah, so we have all kinds of database systems. What's the difference between them? Basically, it's just the data model is different. So in traditional database, what we handle is called a relational model. So why do we need this? Because in a database system, we have to have some way to model the data. Like here, if you do a very simple file-based data management system, what do? You can have a lower-level file system, and you have an operating system on the top. We have a bunch of APIs like read, write, open, close, and so you could improvise or you can design some kind of high-level language over these interfaces. Because so suppose I'm a customer at a bank, and I want to inquire about my balance on my checking account. So if you have just a file system to him, this is not going to work. Why? Because first, for a file system, if you store like a lot of accounts in a file and you grant access to a customer, he's going to see all other people's account, right? If you grant him the right privilege, then he's going to be able to modify his balance in arbitrary way he wants. That's not what you want, right? So that way you need to have some control of it. So how do you do that? Maybe you can improvise some high-level language that allows you to check for balance or update your balance, make a money transfer, something like that. But that means you have to do this for every application you will do. Like if you have a banking application here, there you want to build an e-commerce website like Amazon or eBay. You have actually people buy things and sell things there. It's different, right? You have different set of interfaces. You have checking balance, transfer money in banking, and you have buy things, placing order, and update stock in e-commerce application. So for every application, you have to build a separate interface for that. Then and this is still not enough because these are like programming interfaces. A novice user doesn't know about programming, right? Just ordinary people, they don't know how to program in C or Java. Even if you expose those high-level language interface to them. So what you do, you design a website or you design an app that uses these high-level interfaces to make this functionality available to or accessible to any people, right? So that's if you do this in a file storage system. But what's the problem? The problem is that for every possible application you want to build, you need to somehow design a different high-level language. You have to start from scratch, from the bottom one, the operating system, high-level language, and application program. That's very complex. So what does the database system do? Database system basically, it just handles everything from the very bottom of this hierarchy up to the interface. So that means basically you are replacing the bottom three boxes with the bottom four boxes on the right. So in a database, you have the disk storage, you have a raw disk, and you also have an operating system on that. But typically, a database won't rely a lot on operating system. It just relies on the open, read, close, write. These very simple interfaces. It will also probably bypass a lot of the optimization in operating system. Like operating system tends to have a file cache on a file, right? You will have an I/O cache. So when you read a file, you don't really just go to the disk. So the operating system will remember some of the contents in your file in an internal cache, and it's available to all the applications, like all the programs on it, not just the database. So that means if you read something through that, you will probably go to the system cache first. So some database will rely on this feature, and it will require you just, in an ideal situation, the database system will be the only tenant in the operating system, the only application in the operating system. Then you will probably own the cache. But a better approach is that the database, typically they can ask the operating system, say, hey, I don't want this buffer. I will manage this buffer myself. So then the only thing the operating system is just providing an abstract of the underlying disks, regardless if it's a spin disk or a solid state drive or a flash drive or its memory, anything you like, you can provide an abstract interface of open, close, read, write to database. That database say, you do not do a lot of very complex logics for me. I will handle everything. You just provide me the contents or write things, persist things to the storage. So the database system is a very complex piece. It will provide functionalities like caching, as I said, or it's called buffering, or it will have concurrency control just in case if you have multiple people looking at the data, you don't want them to concurrently write to the same record, right? Otherwise, they will say, here's a simple example here. So if you have a bank account, here's people A, Alice, and Bob. So Alice has $100, and Bob has $0. And
It's
she
too
wants
dark.
to.
It's too dark.
What?
It's too dark.
It's too dark?
Yeah.
Alright. Yeah. Later, I will probably use the touch screen to directly draw on the slides and post it afterwards. But this lecture, since I don't have the right lecture, so sorry about that. Yeah, so say they have this balance, and Alice wants to transfer $100 to Bob. What does she do? She update, say this is X, this is Y. Alice do X equal to X minus 100, and Y equal to Y plus 100. But at the meantime, Bob tries to overdraft his account. What he does, he tries to say buy something. Then he do X equal to X minus 10. Say it's just some groceries. Then, as you can see, you are concurrently modifying X and Y, right? So what could happen? It could end up with two different situations. If this happens first, then this. This is Y. If this happens first, then this, then Bob will end up with a balance of 90, right? This is the first possible situation. The other one is that this happens first, then this happens later. What happens? It will be still 90, but at some point of the transaction history, Bob has a negative balance. Then the bank will say, oh, you have a negative balance, I will have some penalty. So probably he will end up with something less than 90 because of additional, there will be an additional transaction here. And then this is a problem, right? So you might want to have some guarantee that, say, if this whole thing is done in one transaction, you don't want them to overlap arbitrarily, and this will make your life a lot worse, like this real situation. Or even worse, Bob can say, I want to transfer $10 to Alice. It's a different situation. So what he do? He do y equal to y minus 10 and x equal to x plus 10. In this situation, say Bob starts with $10. So what could happen? Remember this can be ordered arbitrarily. Like, it can be done like this. Alice update this x to be 0. Then Bob do this y. Bob do this y equal to y minus 10, right? Sorry, I should do it in a different order. Like this. Right. Then Bob do first add the balance to Alice. That's end up with 10. That's right. And then we deduct this from y. That's fine. We end up with 0. Then we do this. This is 100. Right? This seems perfect because she transfer all the money to Alice transfer all the money to Bob. Bob transfer all the money to Alice. But what if you do this? At first, Alice reads x and y and find out Bob has $10 and Alice has $100. Then she computes this x minus 100. It's 0, right? But before she writes this, she hasn't write this. She just computed this x minus 100, and she also computes this y plus 100 as 100. Then Bob reads everything here, so he gets this 10 and 100 and a 10. Then this value should be 110 and this should be 0. Then what happens? Then suddenly Alice starts writing things to this x variable. That means she writes 0 here, and she writes 100, this y 100 there. Then Bob writes everything back as well. Then it overrides this amount. So that gives you 110 for Alice and 0 for Bob. See, that's weird. Like Alice transfer 100 to Bob, Bob transfer 10 to Alice, but they end up with 0 balance for Bob, $110 for Alice. So that's a weird situation, and this is not okay actually. So this is just an example. We say in real life, if you don't have control on overlapping data access, you might end up with some weird situation. So that's why our database system needs to come in and say, we need to have some concurrency control here so that you won't end up with a not possible situation. Yeah, that's the database system. And what does database system expose to the up-level application? That's called SQL. That's the SQL language typically. So SQL is just like the high-level. Sorry, you can see the screen, I guess. Yeah. So there, the SQL interface in that box, in this box, is just analogous. It's an analogy to this high-level language. That means SQL is a language, and it's an interface to manipulate data and access data, modify data in a database system. But this is a standardized thing. So they have a ISO standard for SQL. So that means you can write your SQL statements for this database, for that database, and all your different applications can use the same interface. So that if you switch database or you write a different application, you do not have to use different interfaces. That makes your life a lot easier because you can reduce a lot of modules of your applications, and it reduces your learning cost. Like you only have to study one system, just as if one system. In reality, actually, SQL is not perfect. All people have different kinds of dialects of the SQL. It's just like it's different for like you have different compilers for C or C++, right? You have GCC, C++, and you also have Visual C++. But although they share the same standard for C or C++, but they all have some additional features on their own. So SQL is something like this. SQL has a standard. So basically the standards are the same across different databases. But when it comes to different database systems, they also have some tricks. They have different syntax for some additional stuff you might want. So it's not perfect, but at least for most of your application, most of your logic can be expressed in a standard thing, so that you don't have to learn a lot. Even if you have to learn something, it's easier for you because everything is similar. You can put a select here in SQL Server. You can also write a select for MySQL. You would expect they will return the same result. So yeah, then in this hierarchy, you will also have the application program that uses this SQL interface, and that exposes a very much friendlier interface to the user. So that's why we have the database system. Basically, database system is going to handle a lot of the mess of data management in this whole hierarchy. So, and that's why we have a very database system are very complex, and sometimes you will find database doesn't run as fast as you think it will be, because you will need to handle a very generic setting. You will need to handle different situations so that it cannot know beforehand what specific situation you are at, but it will be able to at least give you a correct answer. And the result will be intended, and you will try to make things as fast as possible. So yeah, so far so good. Any questions about that? Okay, so yeah, so if there's no question, we will look at the hierarchy of the internals of a database management system. Remember, as we said, the database is built upon very primitive operating system interfaces. That's where this part is. The data files, index files, system, and metadata files. These are just typically they are just ordering file in your system, like PDFs or DOC files in your folder or directory. But in database, these files, although they are just a normal file system file, a file in the file system, but they have different format than other files. They won't be in like a table. They won't be a CSV file you can look at directly. They will have some internal binary coding of all the data you have. And with those files, this part, the database will actually use the open, read, write, close, this kind of OS APIs to provide the interface to the upper level modules so that they can read data, write data, and also get some metadata information of everything. Then that's the bottom layer of the database. That's files. And then one level above is data access layer, where so that's basically, so the lower layer is basically just raw files, and on the upper level layer we will have different modules to manage these files. Like if you have a bunch of files across your file system, the upper level, since this is a very complex system, if you have to like use the OS interface every time or very low level interface every time, it will be impossible to make sense of your system and build a reliable system. So that's why we have a middle layer where we have this buffer manager. Buffer manager is basically what we say IO buffer in terms of OS, but here we will go bypass the IO buffer of OS. That means when you read something from the data files, it will go into the buffer first. Then you do buffer is basically a block of memory that holds data files, data pages. Then you will read things, write things there, and the buffer manager also is responsible for like writing data back to the disk and evict pages. That's something like a virtual memory. And don't worry about all these details. We will cover this in later lectures, but this is just an overview. And also there's like security manager, more precisely, it's like you have something that allows you to manage who has the privilege to access what data. That's like if you are a customer of a bank, you can only access your own data. You cannot access arbitrary data. But if you are like a manager in there, you probably have more access to the customers in your branch or some other customers. If you are all higher level executives, maybe you can look at all the data you want. That's some kind of security management, what security management does. You also have this file index manager, because for the purpose of getting a better performance of the database, like you want to access data faster and maybe more efficiently, then you probably need multiple copies of the data and store in maybe files and indexes. Index is just a special file that contains a fast access method that is like for searching for things. I can put it that way. So basically you have multiple copies of the data, so you have so that's why you need to have some kind of manager for that. And also, as I said, you need to do transactions like this. You do not want to end up with a weird situation where your data is not consistent. So you have this transaction manager to do that. And in particularly, there are concurrency control where you do not want two people to modify things concurrently, and also they have to do this in some reasonable order. And you also have this crash recovery because like machines are not perfect. They can crash. They can the disk can be damaged. You can have a power loss. Then since a lot of things are in memory, and some things are in memory, some things are on disk. In-memory stuff are not saved when you have a power loss, right? You lose everything in memory. So during that crash, you lose a lot of data, but how do you guarantee you can still see those data when you restart the database? So that's what crash recovery does. So that's the data access part. Basically, it only concerns about how do you access data in a file, or I would say in a table or something, or index. Then, but only with that, your life is not, it's still not easy because you only have primitives to read some particular data item. I will just say data item. Later we will have some more technical terms for that. But your life is not still easy. It's not still easy because you say you want to find this balance for Alice, balance for Bob. There are X and Y here, but in reality you have so many data that you don't have a proper name for them. Then, or they are so hard to use. So for a vanilla user, you do not. For a novice user, you do not want to handle this kind of details. So that's why we have this query evaluator. You can issue queries about these data items. So say I want to compute what's the average balance of all the checking accounts that was opened in my branch. Then you probably need to write a SQL query for that. Then this is a query, also a query. There's a query plan inside the database system. So a query plan is something like an intermediate language. If you are familiar with the term from a compiler community, it's called intermediate representation. It's something like that. Or you can think it as some kind of program language, but with limited usage inside the system. So basically, you have this plan, which is describes what your query is. Say here, find out all the checking accounts that is opened in my branch, and also do a sum of the balance. Do an average of the balance. That's your query. So basically, the query evaluator will try to optimize this plan because you might have different ways of executing. Saying given you have different copies of data, you have different ways of computing the same quantity, you might end up with dramatically different performance. So that's why we have this plan optimizer. When you get a good plan, you stick to the plan, right? You just execute that. That's called a plan executor. Basically, it just carries out all the data access through the data access layer and return a result to you. But that's called a plan. But plan itself usually is a tree. I mean it's a tree. Tree like it's a data structure where you have parent node, child node, right? So a tree is not very easy to express in plain language. Like if you just want to describe a tree, since there are multiple attributes in it, you might need to specify that one by one. That's hard. So that's where we have this SQL interpreter. That's basically SQL is a declarative language where you can just say I want something, like select all the customers from this branch. So that's essentially what you say in SQL. But since you have two different languages, the SQL is a front end language, and the plan is an intermediate language. So you need to have some kind of compiler or interpreter, whatever term you want to use. You want to translate that SQL statement, which is basically a declarative thing, to another language, to the plan tree language. So that's where you have this plan generator and also that SQL interpreter. Actually, in the system, usually you have a SQL parser which produces a parse tree. Then the parse tree is given to the plan generator, then it generates a plan, logic plan. Then up to, from the bottom database, the storage layer, up to the SQL interpreter part, these parts are inside the DBMS. And then build on that, you have application interface. That means you build your apps based on the SQL or whatever interfaces the database system may expose to. So that's just an overview of that. So this course, as I said, we will cover from bottom up. That means our first part, after we review this data model thing, we will first cover the bottom part, the storage layer, the database storage, the files, the indexes. And then we will go to the buffer manager and file and index manager. Then we won't cover a lot about the security manager. That's a totally separate issue. So that's going to be, that's out of the scope of this course. Then the transaction manager is actually more involved. So we will leave that part to the very end of the class. Just suppose you only have a single threaded database. You can only have one user at a time. Then we don't need this transaction manager. We still need the crash recovery, but we will leave that towards the very end of the class because that's the algorithm is more complex than the other parts. Then build on that, we will cover query evaluator, the plan generation, plan generator, plan optimizer, and plan executor. How do you model this? How do you design algorithms to give you a good plan? Something like that. The SQL interpreter, as I said, this will not be in the scope of this class because that's more related to how to build a parser. That's a compiler course thing, right? So, but we will cover what SQL looks like, and we will have so basically we will have SQL as our language of saying what query we want. So later we will look at how do you translate from a SQL to a plan, and what. So given the SQL, what's the plan? What does the plan look like in the system, and how is it executed in the system, and how the results are returned to the user? That's what we will see. So that's about it. Basically, just and as I said, the last bit of this is the transaction. It's a huge part. So basically, this course have four major parts: the storage, the buffer manager and file index. That's the data access part. Then query evaluator, that includes plan optimizer and plan executor, and the final bits are the transaction manager and crash recovery. That's a big picture of the system. So, any questions so far?
Did you say we're going to cover the transaction manager?
We will cover transaction manager towards the end of this course. We will cover it, but not in the very beginning of the part of it.
Is this DBMS itself an application for analytics?
Yes, it's just typically it's just an ordinary program. So it's a user space program, and you have everything user space. But sometimes they will use, say, bypass the buffer manager because they don't want this to interfere with its internal mechanism. Something like that, you will have some more involved settings to design for different systems. So So this, I think I've already explained the benefits. Basically, why use a database system? Because OS only provides an interface to run a disk. So it's hard to use for application builder and end users. So and also there are other issues like privacy, recovery, and abstraction. You also have this per language thing. You want very easy to use language, and it has to be precise. And also you want efficiency because two different programmers can end up with different programs that perform dramatically different, can be orders of magnitude. And also you want to keep your data secure. That means you don't want some people to access your data. Then the database system has to enforce that. And also the most important, so for this lecture, actually the most important thing we're concerned about, just this lecture, we will talk about data integrity. That means, so people make mistake, right? So you do not want to have corrupted data. So if you want to keep the data integrity, you have to first define what's the data integrity, what's required in some data. So that's why we have this data models to provide that. So basically, database management system will provide all of this. So that's why we need to have a database system on top of the operating system. We only have 5 minutes left. I'll just have a start, of the relational model, but I will probably just review these things again later. I just cover end with this lecture, slide 6. It's just a preview of the next lecture. So the data model. Well, what are data models? They model the real world data. Like they models the real world. What's a real world? Like as I said, you may have a bank. In bank, you have different things, different entities like bank accounts, customers, employees, maybe some other stuff like you may have different things, as I said. So this data model actually tries to model all these things in a very precise way, so that you can express what should be recorded in your data. What's the type of them, and so what should be stored in the database. And also you might want to also define what's a correct thing to do with this data. Like when you transfer a balance, you do not want to end up, so you want exactly the amount deducted from one people and added to another people. You do not want to end up with the wrong amount. That's something about the correctness of your transaction. And also there's an integrity thing, like, so maybe you have a bunch of branches. A customer opened his account in this branch, then it's magnified by this branch. Then if someday you close this branch, you do not want this account to be dangled, right? It cannot be like it refers to a non-existent thing. So then you have to define what should you do and what's the integrity constraints here. So there are many models to model things. Like there are graph models where you express the database as a graph where you have vertices and edges. And associated with them, there are properties. That's a way. Also, you have non-SQL database. Those models, like you can store unstructured or semi-structured data, like JSON, XML, YAML, something like that. That's also a choice. But the most traditional one and the most widely used one, I would say, in real world, is still the relational database. It's so useful that its inventor actually got a Turing award for it. So yeah, so in the next lecture, we're going to go through the relational model and how it relates to the SQL language. and we will explain they are actually not exact mapping. So SQL is based on relation model, but with a slightly different. There are also some theories about this, but for the purpose of this course, this is just we will just focus on the relation. So that's about it.